All right, mathematicians, welcome back. We're going to start a new chapter today, starting with some Algebra 2, some Algebra 1 review. We're going to talk about solving systems of equations by graphing. This is going to use all of your graphing skills for a new goal. Let's get started. So a system of equations has two different lines that are being graphed, and we're trying to see where they cross, if they cross. If, when we graph two lines, we end up with a situation where the two lines cross at a certain point, then we say the system is consistent and independent. If it results in a situation where there are two parallel lines that never cross, then there's no point and they are inconsistent. And if the graph is the same line and we just don't know it, we run into a situation where they cross at every single point, and we would call them consistent because they do have a place they cross, but it's dependent on being the same line. Independent is someone who's, doesn't need anybody else, they're alone. That would be the one point here. Dependent is, people that are codependent, they're never apart. That's what's going on here. So we're going to be labeling all of our graphs. We've got 4 examples today. We're going to label them with these words after we find the solution each time. Let's go ahead and look at our first examples. So on our first couple of examples, we've got these graphs. They're easy to graph. They're in the form that we normally graph in. The first one is 2x plus 1. We're going to start at 0, 1, put a point there. And then this slope is 2 over 1. We're going to go up to right 1, up to right 1. Whoops, hold on. And this is not like the inequalities. These are solid lines. We're going to graph that line. And then we're going to graph the other one. We're going to start at 0, 4. I'm going to use a different color just so we can tell the two lines apart. 0, 1, 2, 3, 4. And then we're going to go down 1, right 1. And it becomes very clear where these two are going to cross. I'm going to go ahead and draw my line. So they cross right here. Looks like that is the point 1, 3. And we go back and we're like, okay, we crossed at a certain point. That was a system that was consistent and independent, sorry. You can probably hear the sounds of the coffee maker in the background, but that's nothing to be concerned about. On the next one, we are going to start down 1. And then it says up 4, right 1, up 4, right 1. That's all we can fit there. So down 4, left 1. There's our first line. And then the other one we start up 2. And then up 4, right 1, up 4, right 1, down 4, left 1, down 4, left 1. And it becomes very clear that these are parallel lines. There is no place they are going to cross. And if there's no place they're going to cross, that means, according to our words from before, this system is inconsistent. So that's 2 of the situations. By the way, on the first situation, I should have mentioned, it's not enough to just graph it at all. You have to tell me. You must tell me where it crosses. If you don't do that, you are not done with the problem. You will get an incomplete answer. So now I've got 2 equations that are not in graphing form. So let's start with the first one. We've got 2y plus 6x equals 8. We are going to subtract 6x because we're trying to get this into y equals form. So we've got 2y equals negative 6x plus 8. We're dividing by 2. Y equals negative 3x plus 4. So we're going to start up 4. 1, 2, 3, 4. And then we're going to go down 3, right 1. Up 3, left 1. Until we have a line. We're going to pretend for the purpose of this video that this is totally a straight line. And now we need to do the same thing with the other line. So minus 12x, 4y equals negative 12x plus 16. Divide by 4. Y equals negative 3x plus 4. Uh-oh, I'm pretty sure that sounds familiar. This is the same line. This line is going to cross everywhere. So there's not one point where it crosses. There are infinitely many solutions. Not infinity, but infinitely many solutions. That makes this one consistent because it has solutions, but dependent on being the same line. And we've got one more that we need to change. So we got 2y plus 8x equals 16. We're going to move the 8x to the other side. 2y equals negative 8x plus 16. Divided by 2. Y equals negative 4x plus 8. So we're going to go up 8, down 4, right 1. Get our line. And then we're going to do the other one, negative 3x plus 6y equals 30. Add 3x. 6y equals 3x plus 30. Dividing by 6, y equals, whoops, there we go, 1/2 x plus 5. We're going to start up 1, 2, 3, 4, 5. We're going to go up 1, right 2. That looks weird, huh? So we are going to go on ahead and draw the line. And I can't tell where they cross. So this point is, now it looks like it's a little over halfway, from 0 to 1, and a little under halfway from 5 to 6 up. So I think we've got to go with something like, it's an estimate, like 0.7 and 5.3. And this shows us the limitations of this. We can only use this method accurately when it lands on an exact point. So the next lesson that you hear is going to be finding mathematically how to find the answers. Because we have situations like this where we know this is not the exact answer. We do need to label this one. It has an answer, so it is consistent. And it has one answer, so it is independent. But yeah, the next lesson will be about mathematically finding the answers, which we learned in Algebra 1 just like we learned this, but we want to go ahead and review it just like we reviewed this. You have an assignment, and we will see you again in the next lesson.